Okay, so we're going to talk about the 5-number summary and what we would call box and whisker plots. And to begin, we're going to talk about the 5-number summary. So the 5-number summary is a way to summarize our data based on something called quartiles. So you're going to hear the word quartile quite a bit. A way to summarize the data based on quartiles. What word do you sort of see in the word quartile? Quarter. Yeah, tile. True. Okay, can't deny that. But quarter. And what do you know about quarters? It breaks stuff into 4 spots, right? So like we could break up $1 into quarters and we have 25 cents. A basketball game is broken up into quarters. Okay, or high school basketball is, right? College basketball is not. Is that true? Is NBA basketball in quarter or halves? Quarters, okay. It's weird to me that they have different rules. But what that means is it divides the data into 4 equal groups. Okay, so we have the same number of data points in each of the 4 groups, creating like groups of 25% of our data at a single time. Now, the values that are included in the 5-number summary are this. Start with your lowest value, which is your minimum. And then I'm going to put the next 3 up at the same time. It's called your first quartile, your second quartile, your median, and your third quartile. So I'll give you a chance to write those down, then we'll talk about what that means here in just a minute. So the final value is the maximum, and those 5 numbers break up our data into 4 sections. Okay, 2 sections within the box, and then the whiskers on the outside of the box. And each section of the box and whisker plot represents 25% of your data. So off to the side, it talks about interquartile range. It's the middle 50% of your data. So they're talking about this piece right here, the middle 50%. I won't ask you about interquartile range on the project, okay? But if you wanted the interquartile range, it's much like finding the range for the data set, which is max minus min. The only difference here is you're only concerned with those median values. So you take the third quartile minus the first quartile. Now, I say this on another slide, so I'll have you write it down on the next slide. But if you're like unsure about that Q sub 1 and Q sub 3, the first and the third quartile, those quartiles are just more medians. They are the medians for the lower half of your data, that's Q sub 1. And the median for the upper half of your data, that's Q sub 3. So it's just saying, let's take our whole data, divide it in half by the median, and then let's divide those halves in half, and we call those the quartiles because they're breaking them into fourths. Okay? So this next slide is going to tell you how to take these 5 numbers and make a box and whisker plot. So I would definitely write down the steps to the box and whisker plot. Okay. The box and whisker plot is the visual representation of the 5-number summary. So I have 6 steps listed to creating the box and whisker plot. The first step is make sure you've put your data in order. Since we're finding medians, that's one of the really important things to calculating a median, is to make sure that you put your data in order from least to greatest. So we want to do the same thing for the box and whisker plot. Okay. After you put your data in order, it will be really easy to do step 2, which is find your min and your max. That'll be the left and the right side of your data, if they're written in order. Then find the median. Step 3, nothing new. You know how to find the median. Count in from the sides till you get to the middle. If you have an odd numbered data set, it will just be like the single number that's in the middle. If you have an even number data set, when you get to the middle, you'll have 2 numbers. And what do you do with those 2 numbers? Add them, then divide by 2. So take the average of those 2 numbers. Okay, so find the mean of the 2 in the middle. Okay, so up until there, you're okay with steps 1 through 3. You've done that before. Step 4 and 5 are going to be new to us. We're going to calculate more medians, but this time we only look at half of the data at the time. So don't include the median in the lower or the upper half of your data. The median gets left out. Identify the data that's left over, that is your lower half. Identify the data that is your upper half, and then find the medians in those smaller sections of data. That'll be your quartile, your first quartile, and your third quartile. The last step is to sketch your box and whisker plot. I'm going to add one thing to step 6. And that is to use an even scale. The reason being, if you choose not to use an even scale, you may not get the best picture in terms of how your data is actually spread out. So I'll give you 2 examples, one that's bad and one that's good, of how sometimes people could take a lazy route to drawing the box and whisker plot, and then we don't really get good information from it. So here's a bad example that I sometimes see. People draw me a box and whisker plot, something like this. Then they give me some numbers. For the 5-number summary, and they say, there, it's your box and whisker plot. And I agree, it has the shape of a box and whisker plot, okay, and it has the 5 numbers that are part of my 5-number summary. But what I don't really get here is a good depiction of what the spread is between the actual numbers. So a way I could correct this problem is make myself an even scale. So like I have to go from number 1 to number 17. So I might go like from 0 to 20, and I'm going to scale by 3s. Doesn't matter what I choose. So I'm going to go 0, 3, 6, 12, 15, 18, oops, not 81. And I've hit my, or I've got to my max point, so I wouldn't have to keep going if I didn't want to. Now I just plot the box and whisker plot above that scale. So like where my 5 numbers are 1, 3, 5, 10, 17, I can say 1, 3, 5, 10, oh, I skipped 9, didn't I? Nobody yelled at me. 12, 15, 18, 10 is about right here, and then 17. The 3 numbers in the middle, the quartiles and the median, those are going to be my box. So I would draw my box right here. And then I draw my whiskers out to my min and my max. But this visual is a lot different than the first visual. Okay, here I can actually see on the left side my whisker and that very first piece of my rectangle box are very small. Meaning in those sections, my data are very close, very clustered, because that's still 25% of my data in each of those. But on the right side of my box and whisker plot, my data starts to get more spread out. Okay, so whatever my numbers are, they're further away from each other, and there's more distance between the different data values. Okay, so you want to use an even scale so that you can see some of that spread. Here's our example that we're going to do, and like I said, I think it would be really good to add this into your notes so that you have an example to look at later. And you might want to just list the data values with me when we put them in order, because I'm going to put them in order at the very beginning. They're not in order now. What do you identify as the lowest data value in that data set? 23? So I'm going to start with 23, and I'm going to fill in all my 20s first. 23, 27, 29? Did I miss any 20s? Well, it looks like I got them. Then I'm going to go into the 30s. So I need 30, 33, 38. Does that seem right? 30, 33, 38. Okay, so I'll cross those out. Then I'm up to 40s. 40, 42, 43. And then I have a 51 left over. And I always like to make sure that I have all my points. I recount them. Like there were 10 in the original data set, so then I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I wrote down all the numbers. So I don't want to accidentally leave one out. Now let's make our 5-point summary. So off to the side, I just list out like what my 5 points are. Min, quartile 1, median, quartile 3, max. Follow your steps that we wrote down on the previous slide. After you get everything in order, find the min and max is very easy, right? 23 and 51, so I'll label those. Then we have to find the median. So the median is where I start on the edges and I count in towards the middle. Because I have an even data set, I should land on 2 numbers in the middle, and I've got 33 and 38. What do I do with those to find the median? Add them up, divide by 2. So what is 33 plus 38 divided by 2? Okay, 35.5. That's my median. Excellent. Now remember, on this next step that's kind of new to us, when we're doing the lower and the upper half of the data, do not include the median. Well, it just so happens that our median wasn't really included in the data anyway, so that works out fairly well for us. The number on the left that we use to calculate the median is part of the lower half, so 33 and everything below it is the lower half of my data. 38 and everything above it is the upper half of my data. And you should make sure that like you have the same number of data points in the lower half that you do in the upper half. Looks like I have 5 in the lower half and 5 in the upper half. Then you know you have halves. If you have 6 in one and 5 in the other, you don't have a half. You have an issue. Okay, so you got to go find out what's wrong. And then to get those quartiles, just find the medians. Okay. So what's the median, or what's in the middle of this lower half of data? 29 is in the middle, so that'll be my first quartile. And what's in the median or the middle of the upper half? 42. So that'll be my upper quartile. So they're actually really easy points to find. It's just that you have to separate your data into the 2 halves. Okay. Last step is graph it. but before you graph it, pick a scale. We have to go all the way from 23 to 51, so like 20 to 50 or 20 to 60. What do you guys want to scale by? 5. Okay, that seems reasonable. I wouldn't go much lower than 5 because otherwise I'm doing a lot of writing. Okay, so I pick like 5 or 10. I'm going to start at 20, and I'll go 25, 30, 35, 40, 45, 50, 55. And keeping a nice even distance in between all of those numbers. When I create a box and whisker plot graph, I generally just plot all 5 points above that line, all at the same time. So like I'll plot 23, 29, 35.5, 42, and 51. So I got all 5 points plotted. And the 3 in the middle, the quartiles and the median, those are always your box. The min and the max are really just like where your whiskers go out to. So I'll take those middle 3 and go ahead and draw my box. And then my whiskers out. So I've got a visual representation of my 5-number summary, and what I can say after I've graphed that is for that particular set of data, it's pretty evenly spread out. I do see some sections that maybe appear to be a little bit shorter, but in general, I'd say I have a nice even spread. Okay. Does anybody have any questions or clarifications they'd like to ask right now? The last slide that I want to show you, and this will be helpful for when you're working on your project, is what if you have 2 box and whisker plots, and I graphed them on the same scale so that they're like even scale on both, and then I can compare them. What could you tell me looking at the blue to the red, like how are they similar or how are they different? What are some things you notice between those box and whisker plots? Which one does? The blue one looks a lot bigger. I think everybody can easily spot that right away, correct? What does that mean if you have one box and whisker plot that's bigger than the other box and whisker plot in terms of your data? Oh, it has a wider range, right? I definitely agreed. The max minus the minimum is going to be greater. Did you want to expand on that? Or was that all you were going to say? I kind of cut you off.
It just has more of the data.
Oh, okay. Now, you said it has more data in it.
As in, like, it uses more of the data that you collected. If it has the min and the max are bigger than a little.
Yeah, I would be very careful about, like, saying that it has more, like, the way that you're phrasing it, I don't know that you mean that, but, like, do we actually know if it has more data or it's using more data? I don't think we actually know how many data points are in, like, you know, because they could be made up of 10, 20, 50, 100 data points. So I'd be really careful there. But I do agree with your initial statement, which was it has a wider range, right? So it's maybe covering more of the numbers. The data set is, I think, maybe. If it has a wider range, that means your data is more spread out, right? So that could be an issue one way or another if you have a large spread in your data. Remember how we've talked about there are some cases where I don't really want my data to be super spread out because then my measures of central tendency might not be the best measures for my data. Okay, so that could be an issue to me. Does anybody notice anything else about the red and the blue box and whisker plot? Oh, the medians are different. So that's something interesting. The median is the measure of central tendency that we use. And you can spot your medians. I'll highlight the median in green. There's the medians in both of those. And something to kind of like follow up on Jackson's note that's kind of interesting. While the blue one covers more distance on the scale, so it has a wider spread of data, what do you notice about the median for the red and the blue? Which one is higher? The red one, right? So the red one actually has a higher median. Which one has a higher third quartile? The red one. Which one has a higher first quartile? The red one. And which one has a higher minimum? The red. The only thing that the red loses on is maximum, right? So I think that is another interesting conversation we could have, is that even though it's not as spread out, and even though it doesn't go as far to the right as the blue one does, that red one may still have like a higher mean because it beats the blue one in all the other sections. It's further to the right. Okay. So it has higher values in those sections. Okay, so that's something interesting we could note. So just kind of